Lithium is a metal with widespread applications in current and future technologies. Compounds of this element are currently used to make glass, ceramics, pharmaceutical products, and most notably, rechargeable lithium-ion batteries. The global lithium demand increased by 250% between 1995 and 2008, from 40,000 tonnes per year to 140,000. This continues to increase exponentially. The growth is almost single-handedly driven by battery production. Think about it. You probably use multiple battery-powered devices every day. Nearly every portable electronic device requires a rechargeable lithium-ion battery, and there is currently no viable alternative to replace these. A leading cause for this exponential rise in demand is the new electric vehicle market, originating from the desire to reduce dependence on fossil fuels. Tesla, the world's leading electric vehicle manufacturer, uses on average 12 kilograms of raw lithium in every battery pack they produce. And with 500,000 cars sold so far, that's a lot of mining required. As the world moves towards renewable energy, governments and corporations are backing lithium-ion battery technology, as high-capacity versions are seen as strong candidates in creating smart grids able to deal with the intermittent nature of green energy sources. Whatever the future holds, it seems the increasing global demand for lithium shows no signs of slowing and is expected to grow by 700% in just 10 years. But where does lithium come from, and how does extraction at the enormous scale required affect surrounding habitats? The truth is, the majority of lithium comes from some of the poorest nations in the world, and its methods of extraction are frequently at odds with the environmentally friendly image of the companies that champion the idea of a greener, battery-powered future. Lithium is extracted from two main sources: hard rock ores and brine water. Despite the fact that it is found in much higher concentrations in rock, ore mining only accounts for around 13% of its global production, whilst brine water mining accounts for a massive 87%. This difference in production is due to the cost-effectiveness of brine mining compared to extracting ore from solid rock. Whilst both extraction processes require a large amount of energy, brine water mining is able to utilise the sun as a free energy source for evaporation. The vast majority of brine water mining takes place in South America. Approximately 85% of the world's lithium resources are located in the so-called Lithium Triangle, a vast area of salt flats called salars, rich in lithium-ion compounds. Mining companies pump water through these salt beds and up to the surface, where the mineral-rich brine is stored in large ponds. These large open-air ponds are then left to evaporate excess water, concentrating the brine, which is then transported to factories where it undergoes chemical processing to become usable lithium compounds. This process can require a staggering 2 million litres of water per tonne of lithium compound produced. The Lithium Triangle is recognised as a biodiversity hotspot. 2/3 of species here are believed to be endemic to the region, making it a conservation priority. The largest threat posed by lithium brine mining on the region's biodiversity is large-scale depletion of fresh water. In this extremely arid region, water is in short supply for both local people and wildlife, but the vast amounts of it required for brine mining must be sourced from somewhere. Mining companies drill below the salars and extract water directly from aquifers. Although the companies argue that this does not affect water availability, local people say there is no doubt that water scarcity is increasing, claiming that nearby rivers are beginning to dry up. Possible evidence of this was a severe drought in Bolivia 2012, which caused quinoa production, the main agricultural export of the region, to fall by 50%. In Chile, the effects of water extraction are clear. Satellite images of the Salar de Atacama indicate that its lagoons and meadows are shrinking. Flamingos, which depend on these wetlands for food and breeding, saw their population size plummet 28% between 1999 and 2014. Studies show that reducing the number of wild flamingos greatly alters the local ecosystems. Fewer flamingos mean that the cyanobacteria they usually feed on grow uninhibited and produce toxins which, in the absence of flamingos, build up to levels fatal for both humans and animals if ingested. Mining companies such as SQM insist that they have no effect on freshwater availability or flamingo populations, but most environmentalists disagree and claim that water extraction for brine mining is desiccating the region and having adverse effects on the local wildlife and people. Direct water pollution from brine mines into the freshwater supplies also poses a risk to the health of local wildlife and people. PVC barriers and pipes used in the mining process have been known to leak harmful chemical material, such as hydrochloric acid, into neighbouring habitats. a large lithium brine mine high in China's picturesque Sichuan province leaked huge quantities of toxic lithium and other chemicals into nearby water bodies in 2009, killing masses of fish and hundreds of yak which drank from the river. Not only did the leak damage and destroy entire ecosystems, it also caused many people who drank from the river to die from cancer-related illnesses. Brine water mining is a highly contentious topic, with growing concern from local people and environmentalists over the potential for chemical leaks and the volume of fresh water extracted. Comparatively, rock mining for lithium requires even more energy and landscape alteration. First, mineral deposits must be excavated from below ground using heavy machinery. These mineral deposits are then refined in a complicated process to be converted to lithium compounds. The majority of lithium ore mining takes place in Australia, where the environmental impacts are largely caused by direct physical damage to landscapes and habitats, the rearrangement of land and disturbance of groundwater reserves. This method of extraction can also lead to high levels of tail water pollution if substances are not managed correctly, as seen with the alternative brine mining method. Because of its increasing value, lithium is sometimes referred to as the white gold of the 21st century. As its price continues to rise and ore mining becomes more economically viable, it is inevitable that more mines will be constructed. Consequently, rushed operations will be poorly managed and maintained, as happened with the gold rush in Eastern Africa, where unsustainable profit mining led to extremely high mercury levels in rivers, wiping out downstream ecosystems. It is the responsibility of governments and mining companies to ensure that history's mistakes are not repeated and that these facilities are adequately managed to protect the environment. After all this effort to extract usable lithium, the average lifespan of a lithium-ion battery in a smartphone is only 3 years. But where do these batteries go when they've reached the end of their lives, and what can be done to reduce lithium mining and its spiralling environmental impacts? In 2017, it was estimated that only 5% of discarded lithium-ion batteries were recycled, with the rest going to landfill. Between 2017 and 2030, it is predicted that more than 11 million tonnes of them will end up in landfill sites. As old lithium-ion batteries can be extremely volatile, not recycling them can have severe implications, such as igniting fires. This happened in Dunbar landfill site, Scotland, and took 40 hours to extinguish. If this can happen to waste, then it can happen to forests and grassland, incinerating healthy ecosystems. The fact is, currently recycling lithium-ion batteries is not financially viable. Lithium from recycled sources costs 5 times that from mining, offering consumers little incentive to utilise this source or invest in recycling technology. What limited recycling programs there are tend to focus on the recycling of more expensive elements within batteries, such as cobalt and nickel. There are companies investing in lithium battery recycling, such as Li-Cycle in Canada, who hope to soon have a low-cost recycling solution that consumes a low amount of energy, produces no landfill waste, and has a 100% lithium recovery rate. Research is ongoing into other sources of lithium, which are hopes to reduce the amount of environmentally harmful lithium mining. But for now, whilst alternatives are little more than theory, the lithium mining industry and its environmental impacts look set to grow unopposed. The environmental impact of the lithium mining industry is strongly juxtaposed to the green battery-powered future it promises. But with the UN warning that humanity only has until 2030 to phase out fossil fuels and avoid catastrophic levels of climate change, lithium mining may be a necessary evil required to deliver a greener future.